El Nino Southern Oscillation models improve long-term, giving us hope. I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, May 8th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
Looking at significant wave heights for the South Pacific Ocean, we see a gale in the deep South Central Pacific with seas in the 26-foot range and forecast to build some while pushing off to the east. So, maybe things are going to start improving this way as well. As usual, we'll start by looking at winds in the jet stream level. This is about 30,000 feet. These winds help support the formation of gales, and when they form, help direct their track. We're looking for a trough that is a push in the jet to the north. That helps create a clockwise flow aloft and down at the ocean surface. And in the southern hemisphere, that's the hallmark of low pressure. Of course, low pressure, if it's strong enough, generates winds. Winds, if they're strong enough, generate seas. Seas, as they radiate away from the fetch area, eventually turn into swell. Swell, when it hits your beach, turns into surf. All right, so we have the weakest of troughs here in the South Central Pacific trying to push north, maybe supporting a little bit of circulation. And that trough is to push off to the east as we get into Monday. The Southern California's cutoff is about 118 west, 117 west, so pretty much out of the window by Monday night. But another trough is forecast behind that on Tuesday. Again, not a lot of winds pushing up into the northeast quadrant of it until we get into Wednesday, and then more winds build under New Zealand, helping to create a better organized trough. Still nothing particularly huge or anything, but notice that the northern branch and the southern branch converge, building winds to 190 knots, offering some help Friday into Saturday. And yet another trough is forecast developing southeast of New Zealand on Saturday. That, and with the combined jet stream, again, look at that. That's a pretty good solid trough there as we get into Sunday, a week out, but offering decent, if not great, hope for swell production. Hopefully the models will hold. Let's go take a look down at the surface. Here we are, surface level pressure, surface level winds, a gale, actually pretty good coverage with 35 to 40 knot winds. Central's almost the southeast Pacific. Most of the fetch, a little bit aimed northeast, but as much east, if anything, sort of limiting its potential to generate swell. Winds building to or in the 40 knot range as we get into Sunday night into Monday, but starting to push out of the Southern California swell window, while a new gale builds southeast of New Zealand with 50 knot winds over a small area, but lifting well to the northeast. That's really what you want to see. That continues into Tuesday and then even Wednesday, and then a little bit beyond that with additional fetch building behind. So whatever this system has, there'll be a roughed up sea state here in front of it, allowing these winds, 50 knot winds, to get good traction on the ocean surface, perhaps helping to support yet more gale formation. And then yet more activity under New Zealand as we get into Friday, building with 40 to 45 knot winds, and then 50, if not 55 knot winds. There you go. Lifting well to the north on Saturday in both the Hawaii and the California and, of course, Tahiti swell window. Looking really good as we get into Saturday night and Sunday, sweeping off to the east and continuing beyond that. So the models are ripe with potential. Let's go take a look at the effects of those winds on the ocean surface. Now we're just going to do a quick review here we're starting at Tuesday. There was solid southern hemi swell for both Hawaii and the U.S. West Coast, though for California it was pretty much marred by a lot of funky winds, a lot of northwest wind swell, and other junky conditions that did not make for optimal surfing conditions. But that system faded out, and then Tuesday, we're going back to May 3rd. We're just looking if there was really any potential in the South Pacific Ocean. On Friday, this is, 3 days ago, a tiny little gale developed in the far southeast Pacific, but really didn't do much. Small, sort of more pushing just off to the east, if anything. And then here we are on Sunday morning, our current gale with 26-foot seas, and there we go. up to 27.9 feet right there. Highest seas over the entire domain of this image, 27.9 foot seas. So this is really our first semi-legitimate gale producer since the last big swell. And now moving forward, all the previous images were hindcast, actual current best estimate of what the sea state was. Now we're going into a forecast, a supercomputer's view or guesstimate based on a whole bunch of physics as to what will happen in the future. So there's always a bit of uncertainty in that. The further out in time you go, the more uncertainty. 29-foot seas forecast as we get later into this evening in the southeast Pacific, building to 30 feet just barely in the northern California swell window, and pushing out of both the north and southern California swell window as we get later into Monday. New gale builds southeast of New Zealand on Monday night. This one with better potential, 38-foot seas, lifting pretty well off to the northeast, and then taking that more familiar easterly track, certainly generating swell with reinforcement energy behind, with seas in the 32 to 37-foot range, but over a very small area. Still, that's good for just consistent, steady swell. Then we're really looking for this other system that's forecast, and here we go on Saturday. Again, a reach by the models, but 39-foot seas, building to 40 feet, building to 45 feet theoretically. And do we get any more? Nope, down to 41 feet. But Saturday and Sunday looking very solid for storm potential, swell generation potential, and still still pushing across the southeast Pacific as we get into Monday, almost a week from now. So good potential long term. Now, you notice we're not talking about the northern Pacific at all, the northern hemi. It is shut down for the winter. There's just, I'll make it easy on you, there is nothing forecast, no seas, even 20 feet anywhere in the North Pacific for the coming week. So we're looking at winds, California here, Hawaii here. High pressure is the name of the game, 1034 millibar. Another little low pressure system. This was today along the North California coast. The gradient between that low and high pressure out at sea, generating solid north winds. And here we are, right about now, 4 p.m. 30-knot winds building off of Cape Mendocino, and 20-25 knot plus winds pretty much sweeping the whole California coast. Off the south side of the high, trades pushing into the Hawaiian Islands, pretty solid at 15 knots or so. So we get into Monday. Winds letting up a bit for California, and even maybe light as we get later in the day for, we'll say, from Monterey Bay northward. Still a Point Conception, pretty strong north winds. Trades continue for the Hawaiian Islands. Tuesday, a relatively light wind pattern. There's no low pressure near the California coast, and the high has jogged off to the west just a little bit, but trades building quite solid for Hawaii at 15 to 20 knots. Wednesday, then here we go. The north wind machine kicks up again, 20-knot north winds, all this generating wind swell, of course. Same thing for the Hawaiian Islands. Large fetch of easterly trades at 15 to 20 knots. Thursday, things lighten up some for North California. Trades continue solid for Hawaii. Notice the high in closer proximity to California than Hawaii. Friday, maybe the winds back off some. Trades continue for Hawaii. Saturday, same sort of deal. Low pressure approaching the California coast. Yet again, really it's more the Pacific Northwest. California continues 20-knot north winds into Sunday. It's just unrelenting, but finally the trades back off for the Hawaiian Islands. So wind swell is the name of the game. Probably quite a bit of upwelling and cooler temperatures if it wasn't cold enough along California. It probably won't make it any colder. I mean, it seems like up in the San Francisco area, you really never get below about 50 or 49 degrees, but when it blows and just keeps blowing, it just keeps that water temperature hovering right in the 50-degree area and just makes it quite cold indeed and very unpleasant. Precipitation potential, we're not really so much looking at rain, but the whites and the yellows over the Sierra. It is snowing this afternoon. Hardly raining at all in the Bay Area, but snowing up in the Tahoe area. We'll see how much they're supposed to get. But anyway, that's supposed to fade out as we get into this evening. And then as we get into Monday, another bout of, we'll call it light snow potential. and maybe some scattered showers in the Bay Area. Same thing into Tuesday night, more light snow, and then it looks like by Wednesday, maybe things clear out. It's hard to say. I mean, there's little pops and bits here and there, so maybe an inch or two of accumulation here and there. More rain for Cape Mendocino as we get into Thursday night and Friday, but not making it any further south than there. Then after that, it's pretty much over. Snow forecast dashboard for Olympic Valley, maybe a total amount of accumulation, around 15 inches, and that's all between now and the next few days as those weak weather systems push down the spine of the Sierra. The real issue here is temperatures. Temperatures low and cold for today, tomorrow, and Monday. That's Monday, Tuesday, and Wednesday. But then starting about Thursday, this is the freeze level, right? This is the elevation. So this is the bottom of Olympic Valley. This is the top of Olympic Valley. You see where the gray is, that's above freezing temperatures, going up to 12,500 feet. So by, let's say Thursday, Friday of next week, again, warm temperatures return to the Sierra. This is probably right in here, the last little potential for any reasonable amount of accumulation of snow, and really focused on the Tahoe area. Conversely, looking further south at Mammoth, we're talking 1 or maybe 2 inches, a little dust on crust. But still, every little bit helps. All right, so let's go take a look long term. What's going on with the Madden Jullian Oscillation and, of course, the El Nino Southern Oscillation. As usual, we first start discussing the MJO, the Madden Jullian Oscillation. We're looking for signs of the active phase of the MJO. There's 2 phases, active phase and inactive phase. Active phase on one side of the planet, inactive on the other. They rotate around the planet on the equator from west to east. The active phase is a low-pressure system. It imparts energy to the jet stream when it's over the Pacific, and also can help create Kelvin waves by reducing trade winds and taking warm water, typically in the West Pacific, and pushing it east. The inactive phase is a high-pressure system, does the exact opposite, steals energy from the jet stream, and then increases trade winds and creates upwelling, and that reduces water temperatures. So we're looking for signs of weakening winds in the West Pacific. This is data from the TAO buoy array, series of buoys strung across the equator used for monitoring El Nino. This is the East Pacific here. This is the West Pacific here. 0 is the equator. Dateline right there. That's New Guinea right there. Doesn't look like it, but it is. We're just looking at the arrows, and this is absolute wind speed, 5-day average. And the arrows point direction. The longer the arrow, the stronger the winds. So pretty strong easterly trades in the East Pacific, pretty strong easterly winds over the Central Pacific, and in the Kelvin wave generation, the West Pacific. This is the area when you get the active phase over the West Pacific, and if it's strong enough, it can take these winds, which are currently moderate in strength, and reduce them, if not out and out reverse them, taking warm water that's typically here, pushing it off to the east. Now, it's not the actual wind speeds that really matter. It's the anomalies, differences from normal for this time of year. Winds are strong out of the east and the East Pacific, but you look at the arrows, they're not going east or west, they're just sort of north and south, meaning that's pretty much typical for this time of year. Central Pacific, the arrow's a little bit more out of the east, so trade's a little bit stronger than normal, and we'll say modestly to almost moderate stronger than normal over the Kelvin wave generation area. Again, if the active phase were here, these arrows would either be non-existent or pointing in the other direction, so no sign of the active phase today. The forecast for the next week. So this is 850 zonal wind anomalies, just fancy words for are the winds stronger out of the east or out of the west? The blues stronger out of the east, that would mean inactive phase of the MJO. The yellows and reds, active phase of the MJO, stronger out of the west, but it depends where they are. This is the whole planet on one chart. So the date line runs right up the middle. Okay, the far West Pacific, about 135 east, so right about there. Okay, Kelvin wave generation area that ends there. So you just draw a little box in there, and it's pretty obvious. Easterly anomalies, pretty strong continuing for the next, we'll say 5 days, but then maybe weakening beyond that. The strong westerly anomalies indicated here are in the Indian Ocean or the maritime continent, not in the Pacific. therefore of no use to us, at least at the moment. All right, so let's go out 2 weeks. This is outgoing long-wave radiation, cloud cover, effectively. If the active phase of the MJO is a low-pressure system, then it creates more clouds. The blues meaning more clouds, less sunlight reflecting off the ocean surface. The reds and yellows, or in this case oranges and yellows, are more sunlight reflecting off the ocean surface, meaning high pressure, meaning the inactive phase of the MJO. 4 different panels here, 5 days a panel. South America, Central America, Hawaii, New Guinea, Australia. Dateline there, equator there. The area we're interested, Kelvin wave generation area right here. Because when the active phase or inactive phase moves over this area, and remember the jet stream goes west to east, this is where all the energy input or removal from the jet stream occurs. So right now we have the inactive phase of the MJO over the Kelvin wave generation area, likely not supporting the jet stream as much as it could. 5 days from now, though, that weakens. 10 days from now, the active phase of the MJO starts moving to the West Pacific and building. This per the statistic model. The dynamic model paints a little bit different pictures, having a bit of a hard time deciding what's going on. Inactive phase, neutral, active phase, neutral. Can you go from the active phase to neutral like that in 5 days? Probably not. That typically means that the MJO, whatever it is probably not very strong, and it's not getting good traction and not working well with this model. In fact, let's dig a little deeper. Here's the same 2 models, statistic model, dynamic model. The MJO moves west to east from the Indian Ocean over the maritime continent to the West Pacific to the East Pacific, under the United States, across the Atlantic, over Africa, back to the Indian Ocean. Where the heavy dot is where the active phase is. So in the Indian Ocean, probably, though there's the central Indian Ocean, we'll say the West Indian Ocean. The further the dot is away from the circle, the stronger it is. So pretty weak. It's got to be out here to be strong. And 3 different model runs or 3 different model types, and the projected tracks all have the active phase making it to the maritime continent, maybe a little bit beyond, and exceedingly weak or weak 2 weeks from now. The dynamic model, the GFS model, showing sort of the MJO racing, moving incredibly fast from the West Indian Ocean to the West Pacific and back to Africa in 2 weeks. That's probably a little bit weird and probably not quite right, but either way, whatever time the active phase is going to spend in the West Pacific, in this case 1, 2, 3, 4, maybe 5 days, that's not enough to get much traction. That probably is the explanation for why we saw what we saw on the previous chart with the MJO sort of jumping all over the place, because even here it looks like the model does not have a good handle on what's going to actually happen. All right, so the CFS model going out 4 weeks. 1, 2, 3, 4. All right, same thing, whole planet on one chart. The date line running right up the middle. Kelvin wave generation area starting about 135 east, so right about there. Our box is right in there. This is past performance here. You can see pretty good inactive phase of the MJO in February and early March. Active phase, the solid contour is the active phase. The dotted contour, kind of spotty, but you get the sense that maybe it was all connected here. So this was the active phase back in March and April, maybe created a bit of a Kelvin wave. And then kind of a neutral, well, here you go, the dotted contour, inactive phase, in control right now. Forecast peaking with strong easterly anomalies, about 4 or 5 days from now, something like that, in the center of the Kelvin wave generation area, then slowly fading out as we get 3 weeks from now, with the active phase building today over the Indian Ocean, and forecast to push into the Kelvin wave generation area about 2.5 weeks from now, creating light west anomalies. Interesting. So then, here's the CFS model going out 3 months, all right? This is past performance here. This is the forecast up here. Kelvin wave generation area, well, the date line runs right there. It starts about 135 east, so right about there. So the area we're interested in is right about in something like this. Now you notice the blues are easterly anomalies, the yellows westerly anomalies. Think of this as the active phase, the inactive phase. We see that the easterly anomalies were filling the Kelvin wave generation area, and the whole way through the winter, are forecast to maybe last about another week. And then there's this shift, and the model has been consistently suggesting this. The time period of the shift, well, about 3 weeks ago it was supposed to happen. It was supposed to have already happened. Now they're saying, well, yet maybe 1 week, 5 more days, and then the shift begins somewhere around May 16th. But regardless, we'll take it if it happens. We want the easterly anomalies out of the Kelvin wave generation area, and we want westerly anomalies, just like is forecast here. Even though they're very light, that's better than easterly anomalies. That will help at least get back to a more normal energy transfer to the jet. In fact, let's overlay the MJO now. All right, so dotted contours are the inactive phase, the MJO. It's very weak right now, giving it its last stand, not even a week from, I'll say over the next week, and then gone. We kind of go into a neutral pattern. Then you get this weak inactive phase, weak active phase, basically just a very, very weak MJO signal moving forward. But let's put the low pass filter on here. All right, so the solid contour here is a low pressure bias. The dotted contour, a high pressure bias. Consider this the La Nina signal, the El Nino signal. Now, we've been watching this, and there was this whole discussion about the leading edge of the low pressure bias, and is it going to make it further into the Kelvin wave generation area? Today, it's at about 160, maybe 165 east. Just looking forward, it doesn't look like it's going to move but maybe 2 or 3 degrees over the next 3 months. The same thing with the high pressure bias. But as long as the easterly anomalies, you notice they're centered right in the core of the high pressure bias moving forward, and that is what we want to see. The westerly anomalies slowly moving in, filling, we'll say 75%, maybe 2/3 of the Kelvin wave generation area. The point being, this should theoretically signal the demise of La Nina. When we were back, you can see it a bit here last winter and the winter before that, this low pressure bias was like filling right over the date line, lock solid. It's slowly trying to ease off to the east. So we'll see. There's some other interesting data from this model. It's what we teased about in the very beginning of this presentation. We're going to get to that in a minute. But there is some things going on with this model that now suggest that maybe this westerly anomaly buildup here is going to have some positive long-term effects for us, and that might even be starting right now. All right, so enough MJO talk. Let's go see what's really going on in the ocean. This is really the long-term part of this discussion. Subsurface temperatures across the equator from 2 north to 2 south, the whole way across the Pacific. West Pacific here, East Pacific here. These little lines here, those X's, those are the anchor lines on the TAA buoy arrays. The X's are the sensors. Sensors collect the data. It all gets processed, run through a model. You get a profile where the warm and cold temperatures in the ocean are. That's the 29-degree isotherm holding steady about 164 east. The 28-degree isotherm holding steady at about 175 east. The 26-degree isotherm, I think it will move back to 140 last week. Trying to make some headway. It was at 120 a couple of weeks ago, somewhere in the, let's say, 133-degree range, so a little bit of a backtrack there. And the 24-degree isotherm unchanged, pushing into Ecuador. But it's not the actual temperatures or the average temperatures. It's the anomalies, differences from normal for this time of year. All right, we see 3-degree anomalies in the West Pacific, a little bit of pocket here in the east. We're not so sure about that. Cooler temperatures below, but it looks like, at least according to this model, and there's differences between the models, and you're going to see that in just a second. This suggests a Kelvin wave, warm water in the West Pacific, has already pushed the whole way across the Pacific, is working its way into Ecuador. We think that's probably highly optimistic. Here is the another model, the same data. Notice the difference. This shows warm water the whole way to Ecuador. This one shows a big lingering patch of cool water between the two, and there is not a connection between these two pools here. We suspect this is probably closer to reality. But also notice, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 4.5 degree above normal centigrade temperature difference here. That's probably a bit overstated too. The other one only indicated 3 degrees. Okay, and this locked right now at about 150 west. It actually had a little finger that made it to 140 about a week ago. That backtracked. We suspect this is a Kelvin wave created from a active phase of the MJO that we showed you. I think it was back in March, somewhere in that time frame. The question is it stalled or is it just regaining momentum? There wasn't a lot of westerly winds associated with this, though we know that the low pressure bias is trying to build over this whole area, maybe giving it a little force. The question is, will this really result in a Kelvin wave that'll make it the whole way across the Pacific? There's a good amount of cold water here. This was the typical upwelling phase of the previous Kelvin wave, and it's not unusual to have, this cold water upwelling and then another Kelvin wave come in behind and wipe it out. I think this cold water is a bit more stubborn than we would like, and that's kind of blocking this off. We'll just have to see. It's hard to tell. Either way, it's a pretty marginal situation. Sea level anomalies, all right? This is the height of the ocean. Take out the waves, take out the wind waves, take out the tide. Is the sphere of the ocean higher or lower than normal? If it's lower than normal, typically that means cold water at depth contracts and then creates a divot on the ocean surface. Warm water expands, creates a bump. Positive anomalies. These are not temperatures. These are positive anomalies. 10 centimeters here, 5 centimeters, that sort of thing. Meaning warm water. Oh, and the equator there, dateline there. South America, Peru, Central America, Hawaii, New Guinea there. Warm water in the West Pacific. There is this little finger trying to make it the whole way across here. And cold water, well, there's Ecuador, there's the Galapagos. Now, there was a minus 15 centimeter pocket right in here. That was about a month ago. That is faded. We're watching, and we believe the expanse of this and the intensity of it is continuing to fade, suggesting this cold water will eventually just dissipate. But the warm water here that we thought was the advancing Kelvin wave was out here last week or 2 weeks ago. It moved back to about here, and now it's retrograding, sort of suggesting that, again, that Kelvin wave is either stalled or dissipating or just not going to make it, and maybe it never really was a Kelvin wave. Upper ocean heat anomalies. West Pacific here, East Pacific here. The reds and oranges and yellows are warmer than normal temperatures. The blues, colder than normal temperatures. You can see last year in the April-May time frame, 1 Kelvin wave. Another Kelvin wave made it across the Pacific. Then a massive upwelling in response. The second lobe, or the second year of La Nina set up with 1, 2, 3 upwelling events. Then in December, active phase of the MJO moved over this warm water, created a Kelvin wave. It pushed across the Pacific. Another active phase set up in the March time frame, and you can see this is that Kelvin wave that we thought was making good progress. And now, just the past week, stalled, maybe even retrograding a little. Cold water here holding at bay. How will this resolve itself? We don't know yet. We're watching. But given the long-term models and the fact that the low high-pressure bias is not moving much, probably not a lot of support for warm water and westerly anomalies past about this point right here. But that said, this is better than, you look back here, it was all cold water almost the whole way to the dateline all last summer and fall. So hopefully we're moving in a better direction. On the surface of the ocean, what's going on? Is the water colder or warmer than normal? Well, it's pretty obvious. South America here, Central America, Baja, California, Hawaii, equator roughly here. The blues colder than normal. Now, the good news here, and you can see this is a classic La Nina signal. The whole equatorial Pacific covered by colder than normal waters. This area of intense coldness, which was really pretty impressive a couple weeks ago, has backed off significantly. It's still there, suggesting strong upwelling, strong trades, or could be that big cool pool subsurface that we saw is advecting to the surface and being squeezed some by the Kelvin wave, that it's somewhere, the leading edge of it's somewhere right around here, but that's probably a bit of a reach. Also, warm water here, it was actually fading. Now lately it seems to be trying to get just a little bit of better of a foothold. The trend for the past 7 days, well, you can see, and we're only interested a couple of degrees north and south of the equator. There's South America, Central America, Hawaii, New Guinea, dateline right there. Equator 0 right there. Still hanging pretty much little pockets of cooling around the Galapagos, maybe a pocket or two of warming. Just really kind of a dead neutral trend. A little bit of warming along Peru, that gives us some hope. We would really want to see a more wholesale signature of warming to think that the cool anomalies that are here are fading out. And then the overview right here again, the density of the coolness right here, not as strong as it was, still pretty cool. A little bit of warming showing up in pockets here and there, but no wholesale sign. I mean, this is still a very clear La Nina signature. No sign that it's dissipating, at least not in the next couple of weeks. The temperature trend in the Nino 1.2 area, this is that area off of Peru and the Galapagos and Ecuador. Temperatures dropped out April 24th. They're trying to make a little bit of a rebound, but they're still 1 degree and 799 thousandths of a degree below normal. Clear La Nina territory, though this is not an official La Nina El Nino indicator area, but you need to be half a degree, if you're below half a degree below normal for 5 consecutive 3 months periods, then you're in La Nina. El Nino would be up here. We were there for a total of 1, 2, 3, 4, 5, maybe 6 days over the past 2 years, I think it was. So clearly no sign of that. We're just trying to get up to here. The official El Nino monitoring region, the Nino 3.4 area, that is the area on the equator due south of California out to about the dateline. Temperatures rock solid today, 0.958 degrees below normal. That said, this looks like either here or here. This is as cold as we got this year in the Nino 3.4 area. Last year we were down to, I believe it was 1.4 degrees or almost 1.5. The models were suggesting that again this year, but we didn't do that. So we actually did a little bit better. And the atmospheric signal, though still strong La Nina, is not as strong as it was last year. All right, so how has the atmosphere responded to these water temperatures? Well, we have the Southern Oscillation Index, difference in pressure between Tahiti and Darwin, Australia. Darwin, roughly in the Indian Ocean. Tahiti, certainly in the equatorial, we'll say Central Pacific. When pressure is lower in Tahiti, that's a sign of, one, either the active phase of the MJO moving north of Tahiti or the development of El Nino. When the index is positive, like it is today, plus 23.38, that's a sign of at least the inactive phase of the MJO or La Nina. In this case, probably more La Nina. The index, you can see going back the whole month, it's been strongly positive. We got up to 31.44 in April. Okay, so this is kind of noisy though. 30-day average, 18.51, still clearly in La Nina territory. We were up at 20.07. That was the highest of this entire La Nina episode. Interesting because last year's La Nina peaked in the January time frame. This year's is peaking in May. Kind of strange, kind of a head scratcher. It suggests it took 5 more months to get the momentum to actually reach about what it reached last year in January, suggesting that this La Nina, this second year of La Nina, not as strong as the first year. The 90-day average today, plus 12.96, and we were up, what was it, 13.69, I think was the peak. Last year we were up at 15, so again, not as strong as last year. In fact, let's go take a look at the graph. Here's the 30-day SOI graphed out, all right? 2020, we were in weak La Nina. As we got into the later parts of 2020, steadily upward moving SOI driven by these upward spikes are the inactive phase of the MJ up to 20, about 20 and a half, 21. We got a bit of a break last spring. Then the summer, the upward trend started again. Here we are just past today. This one says plus 24. This is a little bit different data set, calculated differently than what we just saw. But still, basically, the January spike in 2021, then here the April or May spike in 2022, a later peak than the year before. All right, so the forecast for sea surface temperatures in the Nino 3.4 area. This is the raw data, and this is what we were teasing about early. The models previously had temperatures dropping down to minus 1.25 degrees in May, at one point even minus 1.5. Now all of a sudden, that's gone. This model, which is the most conservative of all the models, is now saying we're as cold as we're going to get this year, and maybe as cold as we're going to get at all in terms of La Nina. And by the time we get to July, coming tantalizingly close to being in the normal range, so we get into the fall, falling to maybe, about 3/4 of a degree below normal. Then as we get into December, temperatures returning to, well, normal really would be up here, but certainly out of the La Nina range. Now that's the raw data. The PDF corrected even improving the situation a little bit more. Definitely saying we're as cold as we're going to get right now, and it's all looking better from here with temperatures moving into the just above the minimal La Nina threshold by July. That really bodes well for this fall. Temperatures falling again to about 0.7 a degree below normal, and then rebounding as we get into December, but still just slightly La Nina. The point being, the models, and we've been having this whole discussion about a triple dip La Nina, well, it doesn't really look like that. I guess theoretically, yes, you could say we would technically still be in La Nina, but it'd be the weakest of weak La Nina conditions. Then after January, well, even if water temperatures do return to normal, or something even smelling remotely like normal, the jet stream is still going to take months to recover. So the net effect is this coming winter, we're talking 9 months from now, is still going to be La Nina-like, but not nearly as strong as this year, and certainly not nearly as strong as the year before. So improvements in the most conservative and just the pessimistic models, that's a good sign. All the other models generally suggest a return to ENSO neutral in sometime in the early fall. So right now, a little pause, wind machine in full effect, at least for California, trade strong for Hawaii. No particular swell in the water, but the good news is, in the next couple of days, small system down south might start getting some traction, generating some swell, and certainly that pattern getting progressively stronger as we get a week out, if you believe the models, meaning southern hemiswell to become the dominant swell source, slowly building as we transition into a summertime pattern. Certainly, when there is swell, you better make the most of it. If you like wind swell, there'll be plenty of that. You'll be fine for the next week. Otherwise, maybe it's a good time to go take care of some chores. Looking longer term, the model's still a bit undecided what's going to go on, but it looks like if we are in La Nina long term, it's going to be pretty minimal, and a slow, steady, gradual return to normal or near normal as we get into next winter. Still, net storm activity, storm intensity, all that, probably be a bit below normal. You really would want to be in the El Nino category to get a net improvement, but anything at this point is better than where we've been. All right, that's kind of it. If you enjoyed the video, give us a thumbs up. If you haven't subscribed, please subscribe. Click the icon down there in the lower right-hand corner of this video. You'll get automatic notifications when we post the videos, or go to stormsurf.com. Just about all the data you saw tonight is available there. You can follow along during the week and check your knowledge against the video at the end of the week with the next video. And that's it. Thanks for watching. We appreciate your eyeballs on the screen, and comments. Always welcome. Questions, post them. We'll be happy to answer. We'll see you next week. Same time, same channel. Be safe. Thanks.